This gas sensor module features an MQ-2 sensor. The MQ-2 sensor is a versatile gas sensor capable of detecting a wide range of gases including alcohol, carbon monoxide, hydrogen, isobutene, liquefied petroleum gas, methane, propane and smoke. This module is provided with male header interface and can be easily interfaced with Arduino Omega using male to female type jumper wires. The four male headers are labeled with A0, D0, ground and Vcc. A0 is the analog output of the sensor and should be connected with the analog pin of the Arduino Uno or Omega. D0 is the digital output in form of 5 volt or ground. The level can be adjusted using this variable resistor. Ground pin of this module will be connected with the ground of the Arduino Omega. Vcc should be connected with 5 volts of Arduino Omega. They are used in gas leakage detection equipments in family and industry, or suitable for detecting of LPG, isobutene, propane, methane, alcohol, hydrogen and smoke. As you can see, I have already connected 3 jumper wires. Red is connected with Vcc of the sensor module, black is connected with the ground of the sensor module, and white is connected with the analog output A0 of the sensor module. So connect a red wire with 5 volts of Arduino, connect a black wire with the ground of Arduino, and finally connect a white wire with analog pin A1 of the Arduino. This is a very basic program written for the smoke or gas sensor module MQ-2. The purpose of this program is to show you how you can read this sensor. In the upcoming tutorials, we will be using this sensor with a GSM module. Will be used in making fire alarm system. Will be used with Wi-Fi module ESP8266 for internet-based monitoring. Will also be used in real-time computer monitoring system, etc. So first of all, we start with the instruction integer smoke is equal to A1. Smoke sensor connected with analog pin A1 of the Arduino Omega. A1 is the pin number and smoke is the name of the A1. You can also give it any other name, even you can name it as L, M, N or X, Y, Z. But it's a good programming practice to use such a name which has a meaning. The name smoke clearly shows that with pin A1 of the Arduino Omega smoke sensor is connected. Variable names should follow some rules. For example, no numbers are allowed in the beginning of the variable name. No spaces are allowed in the variable names. And we cannot use the same variable names for different pins. A variable name should be unique in simple words, as your name is unique among your brothers and sisters. Integer data equals to 0. This will be used to store the values coming from the sensor module. Integer LED equals to 13. As we know, in Arduino and Omega we have an LED on pin number 13, so we will be using this LED as a signal that smoke is detected or not. Integer flag equals to 0 to stop the unnecessary repetition of code. If you want to learn in detail how to use flags in programming, then watch my tutorials on how to use flags in Arduino programming. Every Arduino and Omega program has at least 2 functions, which are the white setup function and white loop function. White setup executes only one time when the Arduino Omega board is powered up. White setup function. White means that this function is not returning any value, and the empty parentheses means that this function is not taking any arguments as the input. If you want to learn in detail about the functions, then watch my tutorial on functions, in which you will learn how to use built-in functions and user-defined functions. Serial.begin 9600. This function is used to activate serial communication. 9600 is the baud rate, so this is a function which is not returning any value but takes one argument as the input, which is the baud rate or communication speed. Pin mode function is used for telling the microcontroller that the pin that we are planning to use will be used for reading or will be used for controlling. As in our case, we are reading the sensor values, so that's why we are using it as input. Pin mode LED output, as LED is an output device, so that's why I set to output. Digital write LED low, in order to turn on or turn off a specific pin of the Arduino Omega, we use a function digital write which takes two arguments as the input, the pin number which is LED and a high or low signal. Then starts a while loop function. Now this function will run infinite times until we turn off the Arduino Uno Omega. This function is also not returning any value and does not take any argument as the input. Data equals to analog read SMOKE is. We are reading the sensor and storing the value in variable data. The purpose of these two instructions is to find the exact range of values, like for example, what values we get when there is no smoke and what set of values we get when there is smoke. Later we will use these values with an if instruction for controlling an LED. I tested it in my room and I find out that when there is no smoke the values remain below 230. And when there is smoke the value increases above 230. I will show you this practically once we are done with the programming. If data less than 230 and flag equals 0, which was set to 0 in the beginning, digital write LED low, flag is equal to 1, we change the state of the flag from 0 to 1. So these instructions will be executed only one time as the flag is changed from 0 to 1, so this way there will be no repetition. If data is greater than or equal to 230 and flag is equal to 1, which was already set to 1, then digital write LED high, flag is equal to 0 and there is a delay of 1000 milliseconds, which is equal to 1 second. So now my friends, first of all connect Arduino Uno with the laptop. So as you can see it's connected. Now click on the compile button. Now click the upload. And now let's click on the serial monitor. So my friends, as you can see right now we are getting value of 208, which means that no smoke is detected, and that's why the LED on pin number 13 is turned off. And now let's make some smoke. And now you can see the value is increased to 272 and the LED is also turned on. And as you can see it's further increased.